Hello dear students, welcome to Tejam YouTube channel. So in this session we are going to discuss about the topic that is motion of charged particle in electric field. So what happens when a charged particle placed in electric field? So it experiences force, okay, because of that moves. So what will be its velocity after some time t? What will be its acceleration in a particular direction, that is x-axis, y-axis, or if we could take the component of velocity along x-axis, y-axis, so what will be the case? So we are going to discuss about this topic is from the chapter electric charges and fields from second PUC. Okay, this is from second PUC, as you already know. So now initially let us take the case when the charged particle is having charge q and mass m is placed in uniform electric field. Okay, E, it experiences an electric force, so that is given by Coulomb force, F is equal to QE. That can be also be written as 1 by 4 pi epsilon naught Q1 Q2 by R square, but here electric field is given, so Q into E. So we know that from Newton's law of gravitation, or just Newton's law of motion, we have F is equal to ma. If it is falling, we can take F is equal to mg. So we can write the acceleration produced on the charged particle is QE by m. Why? Because I can write here F is equal to ma, since the charged particle experiencing force, that is QE, in the electric field. If I equate this to m, will come to the denominator. So A is equal to how much? QE by m. So this will be the acceleration produced by the electric field when charge Q is placed in, what is that, electric field. So the acceleration depends on the strength of the electric field at that point, and we have the charge, the magnitude of charge, and mass of the particle also. For example, if proton is given, you can take charge of proton and mass of proton. If alpha particle is given, charge of alpha particle and mass of alpha particle, like that. Now sometimes they will ask you to find the velocity of charged particle after some time. So how will you find out? Let me take. So velocity of alpha particle after some time, okay, is given by V is equal to U plus AT. Since here the charged particle is placed in electric field, its initial velocity will be 0. So acceleration is, just now we have derived how much? QE by m. QE divided by m into time t. So this will be the velocity after some time. Sir, what about the equation v square is equal to u square plus 2as? So there also you can get the expression for v, but in terms of displacement. Okay, so here initial velocity is 0, u square becomes 0, and now acceleration is QE by m. Okay, and what about displacement? You can take along x-axis, y-axis, like that. Let's consider displacement along y-axis. So this is the formula, or you can write S only in general. So this will be the formula for v square, but we want v. So v is equal to square root of 2qey divided by m. So this is the expression for velocity after traveling through a distance y in the direction of electric force, and QE by m into t in terms of time. So by using this, we can find out kinetic energy. So what will be the kinetic energy after some time? This is very, very important for your KCET exam. So kinetic energy is given by half mv square. So v value, if we substitute, we will get half into m and m square. In that m will get cancelled. Let me substitute one by one. V square is e square q square t square divided by m square. 1m will get cancelled. That is in terms of t I'm rating. So I have substituted v value here. So I'll get, what is that? Half into q square e square t square by m. So this will be the formula for kinetic energy after time t. And in terms of displacement, here we have v V square is this much. Let me substitute it directly. So kinetic energy is given by half m V square is this much. That is 2 q e y divided by m. So get cancelled, 2 get cancelled, right? We'll be having q e y. Since we know that E into Y is V, if you have already studied electric potential next chapter, you can write actually, but we will learn this concept in the electric potential and capacitance chapter. We'll discuss about that. If you already know it, no problem. E into Y can be written as electric potential difference between 2 points in which it is applied. Okay. So in the direction of electric field, V decreases. So E into V will give you Y. So this is the expression for kinetic energy in terms of displacement, potential, and time. It's very, very important. Hope it is clear. Shall I move on to the next one? Yes. Now, here we have the case where initial velocity is parallel or anti-parallel to the field. Let's consider here there is a electric field in this direction. Okay. If a charged particle is projected with initial velocity, how much u? If it is a positive charge, it experiences force in the same direction. So force also will be in the same direction. If it is a negative charge, it experiences force, initial velocity is in this direction, but it experiences force in this direction. So it moves in this direction and comes back. Okay, bounce back at 180 degree and moves back in the direction of force. So now, what is the direction of path traveled? It is a straight line. Whether it is bouncing back or moving in the same direction, the path is not changing. Path is straight line. Okay, so it's a straight line. So next we have the velocity after time t. So initial velocity is u, a into t, acceleration produced in the previous slide I have told you, that is given by q e by m. So q e by m you can substitute here into time t. Next, what is the displacement produced? Displacement produced is given by ut plus half a t square, initial velocity is u, time t plus half. Acceleration I have substituted, that is q e by m into t square. So kinetic energy is given by q into delta v or q into e in the direction of x-axis or y-axis, you can write that. So displacement x in the direction of x-axis, y in the direction of y-axis, or this can also be written as half m v square. Okay, so this is about this one. If initial velocity is given, you can write minus half m u square also, because according to work energy theorem, final work done is equal to kinetic energy, change in kinetic energy, that is equal to final kinetic energy minus initial kinetic energy. Okay, next we have, if the initial velocity is perpendicular to electric field. Dear students, here if you observe, here we have a positive plate. Okay, so to which positive charge is given? Here we have negative plate, equal amount of negative charge is given. Okay, now what happens, because of the positive charge given to this or negative charge given to this, there will be creation of electric field here. Then I will project a charge plus q or minus q into it. What happens? Instead of moving in the same straight line, it will deviate. In which direction it will deviate? Since the electric field is downward, the force on positive charge also downwards. So instead of moving in a straight line, it moves in a parabolic path like this. So what is the nature of path? Parabola. So we have to study about this. So let us divide this part into two components, two parts, that is horizontal motion and vertical motion. In horizontal motion, do you think any force acting? No. Its inertia is making it to move in the same direction, so no force acts horizontally. So velocity remains constant. Velocity remains constant. What is the initial velocity? Initial velocity is u. So final velocity is also u only, because there is no acceleration, because there is no force. So no acceleration. Then what will be the displacement along x-axis? So ux t plus half ax t square. Since acceleration is 0, this complete term becomes 0. So only velocity along x-axis is u. So u into t. So time taken to travel through a distance x is given by t is equal to x by u, because x is equal to u into t. This can be written as t is equal to x by u, that I have written here. Clear? Now what about vertical motion? It is getting displaced along y-axis. In this direction it is moving. Why it is getting deviated in the direction of y? Because there is a force acting. Electric field is downwards. There will be force downwards, electric force, that is given by q into e. So there will be acceleration downwards, that is a is equal to qe by m. So because of that there is a deflection. If we study that, I will take one more page. Initial velocity is perpendicular to field. Here let us discuss about the vertical motion. Since positive charge is given to upper plate and negative potential is given to lower plate, here the electric field will be downwards and charge with velocity u is in this direction. So what is the initial velocity along y-axis? 0. There is no initial velocity along y-axis. But when it enters, it experiences force. Because of that, the acceleration along y-axis is given by qe by m, that we have studied in the first slide itself. Then, after traveling through a distance, so its displacement along y-axis. So in the direction of y-axis, if we take x-axis, if we take, okay, let me take like this. So it has got displaced by y. That is given by ut plus half at square along y-axis. ut along u along y-axis, t half at square. Since u is 0, half acceleration qe by m. What about time? Time I have told you, that is x by t. Whatever the time it is taken to travel along x-axis, same time it is taken to travel along y-axis also. So time will be x by u and acceleration is qe by m. So if you solve this, you will get this equation where y is directly proportional to x square. So which equation is this? Y is directly proportional to x square is a parabolic equation. So that's why the nature of trajectory of the path traveled by the particle is parabola. So then velocity after uh, time t is given by qe by m into t, because we have v is equal to u plus at. Initial velocity is 0 along y-axis, so at will be there. Acceleration along y-axis, so this is the acceleration along y-axis, qe by m into t. All the terms I have used here. So then, so what is the deflection produced? Theta. What is the deflection produced? So what is this deflection, sir? This is the deflection. At a instant of time, if you consider, let's consider here itself. So there will be velocity along x-axis and velocity along y-axis. So let me take that. At this point, velocity along x-axis is vx. Velocity along y-axis will be downwards. That I will take here. Velocity along y-axis. If I take this is theta, so this theta I need to find out, means I will take tan theta. Tan theta is equal to opposite by adjacent. So that is Vy by Vx. Vy is given here. Vx is just u. Velocity along x-axis is not changing. In the previous slide we have studied. So the horizontal component of velocity here is not changing. So qe by m into t divided by u. That will be the tan theta. Okay. Next. What is the work done in this case? Work done is given by q into v. So that is equal to, according to work energy theorem, So that work done is given by half mv square minus half mu square, where u is initial velocity, v is final velocity. If in case initial velocity is 0, qv is equal to half mv square, so velocity will get this much. That we have just derived. So based on this, let us see what kind of questions you'll get. Before that, there is one more concept here. Millikan setup, equilibrium case. Let's consider here a charged particle of mass m and charge q is suspended in space or air. Gravity, uh, gravity is there. So it experiences a force g, but charge is given. So if I apply some electric field in this upward direction, it experiences electric force. If these two equal, what will be the electric field required to keep that charged particle at rest without moving? See, for charged particle remain suspended, stationary in the vertical field. So upward force will be equal to downward force. Downward is gravitational force, upward is electrostatic force. Equate them, you will get this. This is also very important case. Now let us discuss about question. Hope you have understood all the concepts till now that I have taught. If I need to improvise the way of explanation, please let me know in the comment section. I will definitely try to improvise my way of explanation. So here we have the proton and an alpha particle are accelerated through the same potential difference. V is same. The ratio of their kinetic energies. Since the question given in terms of potential, kinetic energy in terms of potential is given by Q into V. So potential is same. We need to find out kinetic energy. Kinetic energy is directly proportional to Q. So that is kinetic energy of proton divided by kinetic energy of alpha particle. That is equal to charge of proton divided by charge of alpha particle. Dear students, if I take proton this side and alpha particle this side, alpha, okay, proton and an alpha particle. So what is the mass of the proton? Mass of proton, let us take it as mp, which is equal to m. What is mass of alpha particle? Alpha particle is nothing but 2He4. So mass number is 4. So mass of alpha particle will be almost 4 times mass of proton. So I will write it as 4m. What is charge of the proton? It is E. And charge of alpha particle is plus E, 2E. Charge of alpha particle is 2E. That I will substitute here. QP is E divided by Q alpha is 2E. So E get cancelled. So 1 divided by what is this, 2? That is option B is correct. Correct, no? Option 2 is correct. Moving on to next one. A charged particle of mass m and charge q released from rest. So its initial velocity will be 0. In uniform electric field, the kinetic energy attained by the particle after the distance, in terms of distance we have to find out. So velocity in terms of distance is given by v square is equal to 2as. Correct, now v square is equal to u square plus 2as. Since u is equal to 0, you can use this. Here it is given that 2a displacement is d. I can take 2ad. Okay, now what they are asking, kinetic energy. So how can I write kinetic energy in terms of v? Kinetic energy is equal to half m v square. So half m acceleration a into d into 2 is there. So 2 get cancelled. So m, what is the expression for acceleration? We have derived, that is qe by m. Practice all these formulae. So qe by m into d. So mm get cancelled. So qe into d. That is option A is correct. Clear? Next, an electron enters the uniform electric field E with initial velocity v. Okay, the perpendicular to the field lines. The trajectory of the electron is, it is parabola. Just now we have studied. When the electron or the charged particle enters the perpendicular electric field, it moves in a parabolic path. No other way. Okay. Next, a charged particle is projected with initial velocity u into the uniform electric field perpendicular to the direction of field. The vertical component of velocity after traveling the horizontal distance x is proportional to, we have just derived, that is v, y is directly proportional to x square. I'll show you that slide once again. See here, y is directly proportional to x square, that's why it is called parabolic path. So we consider x square, option B, as your answer. Next we have, if the charged particle of charge q and mass m is at rest in the electric field E, the acceleration of the particle is qe by m, that is option A. Correct, no? Then an electron and proton are placed in same electric field, the ratio of their accelerations, since acceleration is given by qe by m, so charge will be same. Charge of electron is equal to charge of proton in magnitude, you can take the mod. So then acceleration, electric field is same because same uniform electric field is given, so acceleration depends solely on mass. So acceleration of electron divided by acceleration of proton will be given by mass of proton divided by mass of electron, mass of proton divided by mass of electron, that is option B is correct. Next, a particle of mass m charge q is thrown at an angle theta with the uniform electric field. The path of the particle is, so where is it given? So at an angle theta, not particularly mentioned whether it is theta is equal to 0 or not. So let's consider theta is greater than 0. Okay, if theta is greater than 0, it will move in parabolic path. If theta is equal to 0, it will be straight line. So they should have mentioned it other than 0 degree. So let's consider theta is greater than 0, so it will move in parabolic path. Two parallel metal plates having the potential difference V. So let's consider here, there is a plate here. I am just drawing a line. So here it is very sensitive. Let me draw like this. Okay, so here two parallel metal plates having the potential difference V. One is positive and next is negative. Potential difference is V. Between them, area is between them area. Okay, distance d apart. Okay, let's consider area is A and distance d apart. An electron is released from negative plate. Okay, and speed when it reaches the positive plate will be. So here kinetic energy attained by the charged particle is given by E into V. So since its initial velocity is 0, you can take it as mv square. Okay, so 2ev divided by m is equal to v square. V square will come this side. So 2ev by m will be your answer under the root. That is option A. Okay, so charged oil drop is suspended in uniform electric field. So E value is given so that it neither falls nor rises. Here we have the suspended charge. There will be a gravitational force downward, electric force upwards, Q into E. So its charge is given, that is Q, and mass is given, where is it? No, they're asking the mass of the drop is, they're asking to calculate the mass. We know that from this, mg is equal to Q into E. Q into E. So the mass can be written as QE divided by G. Q value is how much? Charge is 9.6 into 10 to the power minus 19 into electric field 3 into 10 to the power 4 divided by 10. So we just multiply this. So 18 28 point into 10 to the power 19, 20, 20 minus 4 is 16. So that is equal to 2.88 into 10 to the power minus 15 kg. So this will be the answer. That is option A is correct. Clear? Next. The velocity of the particle of charge q of mass m entering the uniform electric field E with the initial velocity u along the direction of electric field after time t is. So in terms of t, so what is the velocity? So the velocity of the particle they are asking, v is equal to u plus at. U is there, plus a is qe by m into t. Okay, that is option A is correct. When the charged particle moves in the electric field, the work done by the field depends on the initial and final positions. It doesn't depends on the path taken, doesn't depends on the velocity of the particle, doesn't depends on the mass of the particle. Mainly depends on the initial and final point, because electric field is conservative. Conservative field. Electric force is conservative force. Next we have the proton is accelerated through a potential difference of v. Initial velocity is 0 and its momentum is proportional to. So what is given? A proton is accelerated through a potential difference v. So kinetic energy is given by half mv square, or this can also be written as half m square v square by m. This can also be m into v is called p square by 2m. This is equal to v. Correct? No? Q into v. Kinetic energy is equal to qv. So momentum proportional to, say here if we take p square is directly proportional to v, p is directly proportional to square root of potential difference v. That's why option B is correct. Next, an electron moves through a distance d in a uniform electric field and started from rest. U is equal to 0. The time taken for it is, the electron moves in terms of what? Electric field, distance and all we need. So here velocity is not there. Through the distance d uniform electric field rest. So v is equal to u plus at in terms of electric field it is given. So kinetic energy if I take, so q into v or q into e into d. Yeah, this is kinetic energy, half mv square. Yes, we can use this formula. So v is given by ed. So this side e q d into 2 divided by m under the root. Array, what happened? Yeah, under the root. Is equal to v. So this will be the answer. That is in which option do we have this? None of this. QE, because half mv square is there. 2d. What about charge? Why is charge there? I think typing mistake has happened here. E should be here. Q. That is option A is correct. Clear? Next. This is very, very important for KCET. Most important question. A particle of mass m charge q is placed at a rest in the uniform electric field and then released. The kinetic energy attained by the particle. So here we have a particle of mass m charge q placed at rest. So initial velocity will be 0 in uniform electric field E. Then the kinetic energy is generated as half mv square. So since the options are in terms of t, we can write v is equal to u plus at. U is 0. So what is a? QE by m into t. So if I substitute this here, we'll get half m. V square is this one. If you substitute this, you'll get q square e square t square divided by m square. So mm get cancelled. You'll be having q square e square t square by m into 2. That is option A is correct. Very important KCET question. Then an electron and a proton are released from rest in the uniform electric field. Which one of these take less time to travel through the same distance? So since the acceleration is given by QE by m, since proton and electron having the same magnitude of charge, so A is directly inversely proportional to m. So since electron is having less mass, its acceleration will be more. So if acceleration is more, mass is less, time taken will be less. So the electron takes less times to travel the same distance because its acceleration is more. It moves faster, that's it. If the speed of the charged particle is doubled and while moving in the uniform electric field, then the displacement of the particle is. So since the velocity is inversely proportional to displacement, I can show you that. Where do we have that formula? Displacement along y-axis. Yes, look at this. Here y is inversely proportional to u square, 1 by u square. Look at this equation. Okay, so compare that y equation with respect to u. So you'll get y is inversely proportional to velocity square. If velocity is doubled, so y dash becomes 1 divided by 4 times v square, because 2v whole square becomes 4 times. So that's why it becomes 1 by 4 times. Okay. Then we have a pendulum bob of mass m and charge q is suspended in horizontal electric field. This is very, very important for KCET. All these questions are important. So this one is different compared to the previous question that we have solved. The angle theta made by the string with vertical in the equilibrium is. Let us discuss about this. Let's consider. Here we have this rigid support. A pendulum bob of mass m charge q is suspended horizontally. So here when the electric field is applied, let's consider this is the charge q. There is electric field applied in this direction. So its force will be QE. Its mass is m, so there will be mass downwards. Tension in the string is T. So electric field is applied in this direction. Gravitational force downwards. If I consider the resolution of these vectors, so this is theta. So this side it is T cos theta. Correct, no? This side it is T sin theta. So we have T sin theta is equal to QE and T cos theta is equal to mg. Just divide this to sin theta by cos theta is tan theta, T by T is 1 is equal to QE by mg. Theta is equal to tan inverse QE by mg. Tan inverse QE by mg. Next we have a charged particle enters the uniform electric field at an angle 45 degree. The component of velocity dash to the field remains constant, always the parallel. The component, if I consider, just a minute, I need to study this. Okay. Let us study this. Let's consider here we have in this direction there is an electric field. And if a charged particle is projected in this direction, it moves in a parabolic path like this. So this horizontal component remains constant. So that is ux. Uy will vary because in the y direction there is the force acting. So I can consider the component of velocity perpendicular